Hello everyone, this is RayPCB, your trusted PCB partner. Today we will introduce the schematic tool in KSV. First, open the schematic editor. We will continue our explanation using the schematic from last time. The schematic editing tools are located in the toolbar on the right side of the schematic. This column is called the schematic editing tools. When a tool is activated, it will remain active. For example, right now I am in selection mode, and I will remain in this mode until I choose another tool or press ESC to cancel the current tool. If I select another tool, the previous one is cancelled. Only one tool can be selected at a time. When other tools are cancelled, the selection tool will always be activated. For instance, if I select this tool and press ESC to cancel, it will automatically switch back to the selection tool. So the selection tool is the default tool. It is mainly used to select the items or content we want to edit or operate on. You can select wires or components. Next, you can highlight nets and net labels using different colors to mark them. If the PCB editor is also open, the corresponding traces for the selected net will also be highlighted. For example, by selecting this, you can highlight this segment of wire. This mainly helps us modify the schematic in PCB, making it easier to quickly select the nets or wires we want to edit in the PCB. The next tool displays the symbol selector dialog, allowing you to place new components. We already used this in the previous episode. When we click it, it will automatically open the component selection dialog, allowing us to place the component we designed ourselves. Let's place one first. We are still in the component placement mode right now. Double-clicking on the blank area will reopen the component selection dialog, so you can place the component again without having to click the tool again. Next is the Hall symbol selection dialog, which allows you to place Hall symbols. After opening it, you can choose from a variety of power sources and grounds inside the power dialog, selecting as needed. For example, let's place a ground connection. Then double-click again to select another one. This time, for instance, we choose a 5 volts power supply, so now we have both power and ground. Next is the line tool, which we already used in the previous episode, so we won't go into detail here. It's mainly used to connect different nets. Next is drawing a bus. The advantage of using a bus is that, for example, if we need to connect 5 wires on this side to 5 wires on the other side, there are 2 ways to do it. One way is to use the line tool to connect them directly, which would result in 5 separate lines. Of course, 5 lines aren't too many, but some components have dozens of lines, and in that case, the schematic would become very complicated. That's when we can use a bus to replace those 5 lines. So how do we replace them? That's where the next tool comes in, the bus entry point. For example, we can strategically place 5 distinct entry points right here, allowing for multiple access points. Then, using the specialized wiring tool, we carefully connect them to the 5 distinct pins located on this particular side. As for the right side, I won't draw it here to save time. It's the same process, just draw it. For the middle section, you no longer need to draw those 5 lines. That's the bus's function. It represents those 5 lines. Of course, with just 5 lines, it may not seem like much of an advantage. But when there are dozens of lines and the distance is greater, the benefit becomes very clear. This one is called a no connection marker. Its purpose is, for example, if we have pin 5 here, whether it's because the component itself doesn't require a connection or because we don't need to connect it in this circuit design, we can place this marker to indicate to the system that these two pins are intentionally left unconnected, not forgotten. This way, when we run the ERC check, the system won't give a warning or error about this I/O being unconnected. When drawing schematics, we should develop the habit of placing a no connection marker on any pin that isn't connected to avoid forgetting to connect certain pins in our schematic design and causing design errors. That's all for the schematic tools we'll introduce today. We'll cover the remaining tools in the next episode. That's it for this episode. If you enjoyed this video, please subscribe to my channel for more content. Thank you, everyone.